Okay, so today we're going to talk about properties of exponents. This is part one of 2 different videos. There are a lot of properties of exponents. There are actually, I think, 7, and today we're going to learn about 4 of them. So get ready. We're going to start it today. So the lesson objective for this lesson is that at the end of the lesson, I can apply the properties of integer exponents. And I've listed the 4 properties that you're going to see in this video. And remember that I think there are 3 more that you'll see in 2.1b. The ones we're going to look at today are the zero exponent property, the negative exponent property, the product of powers property, and the quotient of powers property. Okay, so let's do some quick vocabulary. Some of these words you've seen before, so we're just going to go over them real quickly. I wrote this problem, 3 to the 4th power equals 3 times 3 times 3 times 3 equals 81. And I want to show you the parts of this number. So let's talk about the base first. Okay, the base is the number that's being multiplied. It's the number that's being multiplied, so the 3, okay? Factor is also the base, and it's the thing that's being multiplied over and over. So the factor in this problem is 3, okay? Then let's look at exponent. We've talked about exponents. The exponent is the little number up to the side, and it tells you how many factors of 3 there are. So for instance, this is 4. So there it means you're going to multiply 3 times 3 times 3 times 3, okay? And then the power is also the exponent. So when you read it out loud, instead of saying 3 to the 4th exponent, you say 3 to the 4th power. So they go together. So you might hear the word exponent or power. When I read it out loud, I'm going to say 3 to the 4th power, but we're going to talk about that 4 as an exponent. It's a little confusing, but you'll get used to it, okay? And then let me go back. 3 is the base and the factor that's being multiplied over and over, okay? Term is this whole bunch together, okay? Each piece in an equation is a term, and 3 to the 4th power is a term. Hopefully this all makes sense, but you'll see it as we work through it in this video. All right, so what we're learning in this video and tomorrow's video is how to look at exponent properties and simplify expressions, okay? So the first property I want you to write down, and I do want you to write this down, is the zero exponent property. And what it says is that any number to the power of 0 equals 1. So 5 to the power of 0 equals 1. 125 to the power of 0 equals 1. Why? What does that matter? Okay, here's why that works. Okay, let's look down here. And it says 5 to the 1st power. Well, 5 to the 1st power is 5. 5 to the 2nd power is 25. 5 to the 3rd power is 125. The pattern in this process is that when you go this direction, you multiply by 5 each time, depending on the powers. But when you go in the opposite direction, remember you use the inverse, and so you divide by 5. When you go back to 5 to a 0 power and you divide this by 5, you get 1. That happens in every single pattern. So if you see a number to the 0 exponent, okay, you're going to understand that that equals 1. Write down the property, write the definition, and write one of the examples so you understand. Let's look at the next property. The next property that we're going to talk about, is the negative exponent property. Write that down. The negative exponent property. Any number to the 0... Oh, look, I did that wrong. Sorry. Shoo! Mrs. Hall, you forgot to change the slide. Okay, what that means is that if you have a number to the negative power, or that has a negative exponent, it means divide. So you're going to either put it in the denominator or the numerator, depending on where you find it. So 5 to the negative third power actually means 1 over 5 to the third power. 3 to the negative sixth power equals 1 over 3 to the sixth power. Why does this work? Okay, this is why. Positive exponents tell you to multiply a number by a certain amount, okay? Negative exponents are the inverse, and they tell you to divide. That's why that works. I know we're going fast, but we're going to use these properties tomorrow, so we'll show you how they work. Let's look at the next property. This one's called the product of powers property. Remember, product means multiply. First, I want to look at the table, okay? We're going to fill in the table as far as we can. 7 to the fourth power times 7 to the fifth power. What does that mean? Well, the expression is repeated multiplication. So it's 7 times 7 times 7 times 7. That's 7 to the fourth power. And then 7 times 7 times 7 times 7 times 7. 7 to the fifth power. Now I'm going to look at how many factors there are. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 factors, or 9 times that you multiply 7, and so the simplified expression looks like this, 7 to the 9th power. This product of powers property we're going to ignore for a minute. Let's look at the next one. So this statement means negative 4 times negative 4, that's negative 4 to the second power, and then the next statement means negative 4, forgot my negative there, or I didn't forget it, just doesn't want to show up, times negative 4 times negative 4. Count my factors, 1, 2, 3, 4, 5. So I have negative 4 to the fifth. Oops, lordy. So I have 5 factors, and my simplified expression looks like this. Negative 4 to the fifth power. When you have a negative, make sure that you put your parentheses outside of it. It's real important. Let's look at the x. It can work with numbers and it can work with letters as long as the base is exactly the same. So here the base is exactly the same. So this first one means x by itself. And the second one means x to the fifth power. 1, 2, 3, 4, 5. So now let's count the factors. 1, 2, 3, 4, 5, 6. And so when I rewrite it simplified, it's x to the sixth power. So let's go down and look. When you have two numbers, two bases that are exactly the same, and they have exponents with them, you can, in order to do the product of powers property, to multiply the exponents with the same base, you add them. Okay? So 7 to the third times 7 to the fifth, the way that you would simplify this expression is 7 to the 3 plus 5, which is 7 to the 8th power. That works up in our table. Let me show you what I mean. We already said that our simplified expression was 7 to the 9th power here. Let's try the product of powers. So, we know that the bases are the same, so we're going to add the exponents. 4 plus 5, so that gives us 7 to the 9th power. Did we end up with the same simplified expression? Yes. Let's look at the next one. So, negative 4, and we look at since the base is the same, we have 2 and 3, so we add 2 plus 3, and that gives us negative 4 to the 5th power. Sorry, my handwriting is horrible on here because the graph is so small, or the table is so small. Let's look at the very last one. We see that the bases are the same, so we have x, and then 1 plus 6, 1 plus 5, Mrs. Hall, you're having trouble today, which gives me x to the 6th power. Make sure you write down the definition and this example so you have it in your notes to look at when we do the work tomorrow. One more property. Okay, so we looked at the product of powers property. Now we're going to look at the quotient of powers property. In order to do this, we're going to look at our table and we're going to look at our expanded form. Okay? We have 5 to the 7th power and 5 to the 3rd power. 5 to the 7th power divided by, that means quotient, 5 to the 3rd power. The bases are the same, so this is what it would look like in expanded form. 5 times 5 times 5 times, whoo, there's a lot of 5s, aren't there? Let me make this smaller if I can. 5 times 5 times 5 times 5 times 5, 1, 2, 3, 4, 5, times 5 times 5, okay? Then it's over 5 times 5 times 5. Now, the cool part about dividing is that when you have a number over itself, it equals 1. So what I do to go back and simplify this is I cancel as many as I can. This one cancels, this one cancels, this one cancels. And so when I rewrite it, I have 5 to the 4th power. Okay? And there are 4 factors of 5, so 5 to the 4th power. Let's do the x. On the top, we have x times x times x times x times x times x. Let's count. 1, 2, 3, 4, 5, 6. Good. And now we have on the bottom x times x. We're going to go back and cancel what we can. Cancel, cancel. And that leaves us with x to the 4th power. Will it always be to the 4th power? No, but it just so happens to work this way. So here's what the property says. In the quotient of powers property, to divide exponents with the same base, you subtract the exponents. So 9 to the 6th power over 9 to the 4th, the bases are the same. So we say 9 to the 6 minus 4, and then whatever's left is 2, which is what we did up here too. We canceled. So let's see how that works and see if we end up with the same simplified form. Okay, 5 to the 7th power minus 3, because it's dividing, okay? And we end up with, let me write this a little smaller so you can read it, minus 3 is 5 to the 4th power. We end up with the exact same answer. And then we have x, since x is the same, 6 minus 2, x to the 4th power. So it works. Okay, as crazy as this seems, I want you to go back and look at all of the properties, try these by yourself, and then come back and look at them and see my answers and see if you did them correctly. Now, don't forget, I'm going to expect to see these on your notes. I know this is a long video, but keep it up. You're almost done. Okay, so let's see how you did. 11 to the 0 power. Well, I automatically know that that's 1. Hopefully you did too. Okay. 5 to the 3rd power times 5 to the 5th power times 5 to the negative 4th power. The bases are all the same, so I can use my product of powers property, which means that 5, and then I'm going to take my exponents and add them together. Okay, 3 plus 5 is 8, plus negative 4 is positive 4, so it's 5 to the 4th power. Awesome. I see this one is a negative power, so I know that that means 1 times 15 to the 3rd power. Remember, we're just simplifying, okay? This one down here is dividing, and the bases are the same, so I know that I can, it's the quotient of powers property. So 3 to the 17 minus 9 equals 3 to the 8th property, or power, sorry. It's been a long morning. 3 to the 8th power. And then this one is also the negative. Remember, we're going to do the inverse, so we just flip-flop these, and we get 6 to the 2nd power. If you have any questions, write them down. We will practice this tomorrow. It's probably going to be really confusing until you use it, but make sure you have every one of the properties written down in some type of example so that you can look back in your notes and use those examples.